So the other kind of surface that we're going to be talking about in the scope of this section is referred to as a quadric surface. In 2 dimensions, the way that you get a conic section is from a generic quadratic equation. The same holds true in 3 dimensions. Now, in order to create a quadratic equation, in 3 dimensions. So a quadratic equation in 3 dimensions means that you are allowed to see a square of a variable, one variable multiplied by another variable, or a single variable to the first power. Now that means that the most generic possible quadratic equation could have any one of our variables squared. It could have the product of any 2 of the variables. So we'll call that a constant times xy, a constant times xz, or a constant times yz. We could have any one of these variables raised to the first power, which would simply move around where its significant point is, and we could have a constant term as well. So as many as 10 different possible terms in here. We're going to try to keep it a little bit simpler than that because, well, these guys right here specifically kind of get us into some shenanigans we're not ready for in the scope of this class. It's called rotation of axes, and we'll save that for linear algebra. Now, the big things that we're going to be focused on when it comes to these quadric surfaces. First one is identification. Just like we saw in the previous video, we were able to identify whether something was an ellipse, a hyperbola, or a parabola based off of squares, pluses, minuses, those sorts of things. There are a total of 6 different quadric surfaces, and we are going to use traces to identify. Certain combinations of traces indicate a certain kind of quadric surface. Next thing that we'll do, orientation. Now, the cylinder that we talked about a couple videos ago we said was parallel or oriented about the z-axis. Generally speaking, we're going to say its orientation is parallel to one of the coordinate axes. Could be the x-axis, the y-axis, or the z-axis. We'll talk about how to figure out what goes with what. And finally, we'll talk about a significant point. When it came to our conic sections, an ellipse and a hyperbola both have a center, and a parabola has a vertex. And that was sort of your baseline point where you base the entire conic section off of. So this could potentially be a center, or it could be a vertex, depending on the situation. So please note that in the examples that I'm going to be introducing, all orientations to start are about the z-axis. This is simply for the sake of simplicity, for introduction. We'll get into more complicated stuff later on.